Now, we have talked a lot about variables, not about the numbers. And so what I want to do next is talk about something called scales of measurement. These are also called scales of measurement or levels of measurement. And I know this can be confusing because we learned that a level is a particular category or group of an independent variable. All right, so when we have an independent variable, we're going to have at least two levels. It can have three or four, but you need at least two different groups or categories of your independent variable to compare. So now we're using the word level in a different context, right? So scales of measurement, levels of measurement refer to the way numbers are assigned. The way I should back up. The way a variable is measured and the numbers are assigned, right? So again, it refers to the way we measure a variable and how we assign numbers to our measurements. Now, I want you to appreciate that not all numbers mean the same thing. All right, numbers can mean different things depending on how they were measured and how they were assigned. Let me give you an example. If we talk about the numbers, 1 and 2, sounds very simple, right? 1, 2. Okay, well, what is that? Is that referring to number of objects? Like first, I have one object in the room, two objects in the room. Is it referring to an order, like first place, second place? Those mean different things. Or are we using them to refer to biological functions, like I have to go number 1, I have to go number 2. All right, so numbers can mean different things. They don't all mean the same thing. So the scale of measurement is useful to us because it tells us, once we learn what the different scales are, it tells us what we can do with those numbers. We understand what the numbers are trying to tell us. And in fact, you're going to learn that depending on the scale or level of measurement, some statistics are allowed and others are, I don't want to say prohibited, but highly discouraged. You should not run these statistics if you have a certain scale or level of measurement. All right, so let's look at what these different levels are. There's only 4, so that's easy to remember. They are, and by the way, they're in order here: nominal, ordinal, interval, and ratio. Nominal numbers are considered to be the most crude, whereas ratio are the most sophisticated. All right, and then of course they're ordered from least to most. Now, a good way to remember the order of these levels of measurement is look at the first letter of each word. N-O-I-R. Do you know what N-O-I-R spells in French? Noir. What is noir? It's black. And I like to think that this is just a coincidence, but wait a minute. Noir, black, bleak, statistics? Maybe it's not so much a coincidence. Anyways, so what we're going to do now is we're going to look at each of these levels, and we're going to start with nominal, and we're going to work our way to ratio, and we'll talk about some statistics, that you can run with nominal that you can't do, that you can run with ratio that you can't do with nominal. All right, now, start with nominal. Now, I'm using this analogy here. It's a upside down period, a funnel, whatever you want to call it. But I'm going to assign nominal to this part of the upside down pyramid. All right, so, and the reason why I'm doing that is because nominal is the most crude, which means you can do the least with it. All right, least amount of math. It's the least sophisticated, so it's occupying the smallest piece of this pyramid. Okay. By the way, these are Well, these two are my biological sons, Troy and Burgess, and this is Tyler, who is like my biological son in many respects. All three of them used to play hockey in high school when they were in high school. And I'm using this picture because you'll notice, well, you can't see his number. He's number 8, 28, and 27. These numbers actually fall on a nominal scale. So let's understand why. If you are using numbers from a nominal scale, that means you're not really measuring anything. These numbers are assigned for one of two reasons. Either you're trying to tell one individual from another individual. So on their team, there's only one number 28. There's only one 8 and there's only one 27. All right. And those numbers are used so that at a glance you can see who has the puck, who just sent who flying into the boards so that they'll get the penalty right or something like that. All right, so all we're doing here is we're using numbers to tell one player from another player. Now, that means we're using them to identify individuals. But another use of nominal numbers is we can use them to identify group membership. So common use of numbers that would fulfill this second use would be to, when you're coding variables into SPSS, assign every male participant a 1 and every female participant a 2. So 1 is male, 2 is female. So you see, we're assigning numbers just so that the computer will understand what a 1 means. A 1 to the computer now means male, and a 2 means female, right? So those are the two uses of numbers on a nominal scale. And a couple of other things about them is that these numbers are assigned arbitrarily, all right? So we don't have to say that men are 1, women are 2. We could have reversed it and we could have said men are 2 and women are 1, all right? It's entirely up to the researcher in a case like that, what they want to do for assigning numbers. When we're talking about numbers on jerseys, I'm sure every player has their favorite number, and they might choose that number, so it's not arbitrary in their head, but from our perspective, it's arbitrary. I don't care what number you are, I just want you to have a unique number. Both positive and negative numbers are possible. I have yet to see this, but I suppose Troy here could have been like negative 27, but that wouldn't have done much to his self-esteem, right? So, but in theory, right, you could have jersey numbers that are negative. You could even use decimals or fractions on jersey numbers, but that would break with tradition and that would be kind of stupid and it would drive announcers absolutely crazy. So we stick with positive whole numbers and, we just, again, stick with convention. Now, we are very, very limited to the types of statistics we can run if the data was collected on a nominal scale, if we're using that nominal purpose to either identify individuals or group membership. So basically, there are no statistics that you can run if you're just using numbers to identify one individual from the other. If you're using the nominal number to identify, which group somebody belongs to. So if we do have men are 1, women are 2, then you could use a statistic called the mode. Now, some of you probably remember what that is. The mode is simply the most frequent score. So if in a classroom, I say, there are, 20 2s and 10 1s, okay, the fact that I've got more 2s tells me that I have more women in the room if we coded them men are 1, women are 2, right? So you could use the mode, the most frequent score, but other than that, you're really, really limited to the types of statistics you can run on nominal data. Next up is ordinal, and ordinal is above nominal, and that's because it is more sophisticated, right? So it occupies a larger area because it's more sophisticated and because we can do more math with ordinal scale numbers. So what are ordinal scale numbers? Well, first of all, they're still pretty crude, but unlike the nominal data, with an ordinal scale, we have information about rank order. So, for example, lightest to heaviest, least to most. So the numbers are not entirely arbitrary anymore. They convey information about rank, position, or order. Okay? Higher numbers mean something different from lower numbers. With the hockey jerseys, it's not the case that Tyler is better than Troy because Tyler was number 28 and Troy was number 27, and poor Burgess must really suck because he was number 8. Right? That's not the case. Those numbers don't tell us anything about, worst to best or highest to lowest. But if you have numbers on an ordinal scale, they do. So here would be an example. If we were to look at these individuals, some of whom or all of whom you might recognize, if we were to look at them, we might ask the question, or we might want to rank order them according to height. All right. So if we did that, we'd have to move Austin here. We'd have to, well, actually, he's probably the shortest. Just looking at, this grouping here. So he can stay here. And then who's next? I don't know her name. This is Britain's Got Talent. Well, anyways, we'll put her next because I think, maybe she's next. And then who? Actually, she looks taller than Simon over here. So we'll put her, third now? And then Simon, and then whoever this dude is, I don't know his name, he's going to be at the end. So we can rank order them from shortest to tallest. Or we could have put it the other way around. We could have started with the tallest and gone to the shortest. But the point is here is that once we've got this order, we can assign numbers. So by convention, we start with 1. Do we have to start with 1? No, you could start with negative 16.26, but that would be breaking with all convention, and it would be very confusing. So we're going to start with the number 1, and then we're just going to rank order them. And I forgot the order already. I think it was 1, and then it went 2, 3, 4, and 5. Okay, so these people would be reordered according to their height. Now, how did we assign these numbers 1 through 5? Well, we just eyeballed, right? We didn't get out a measuring tape or anything. It was a very crude and subjective way of ordering these individuals according to height. And that is a very, very important thing to know about the ordinal scale. Your quote-unquote measurements are exceptionally crude. We're not getting a formal instrument out to try and measure height. We're eyeballing. All right, it's kind of like a little bit of a guessing game. In fact, now that I look at these two, I'm thinking, maybe I should have put Simon next and not her. I mean, so it's very, very subjective. All right, so that's a very, very important point to note about the ordinal scale. Now, the other thing to note is that we cannot assume, well, I guess it comes next, but anyways, we'll get back to this. We cannot assume equal intervals, all right? This is what I wanted to talk about next. We cannot assume equal intervals. What does that mean? It means that if we look at the numbers, we see 1, 2, 3, 4, 5, right? So there's a difference of 1 between a 1 and a 2. Between a 2 and a 3, there's, again, a difference of 1. Between 3 and 4, again, that's 1 point different. But that's true for the numbers. It's not necessarily true for what it is we're measuring, which is height. In other words, if we put Austin as 1 and let's put her as 2, the difference between Austin and this woman may not be the same between this woman and the person next to her, next in line, Simon. So maybe the difference between these two is smaller than the difference between her and Austin. Similarly, the next two, right? These two would be compared. I think, if I've got that order right. But anyways, the difference between this person and this person may not be the same as between these two. So they're not increasing in terms of the variable we're interested in, which is height. We're not necessarily seeing an equal increase in height between a 1 and a 2 and a 3 and a 4, etc. So the numbers all go up by 1, but the underlying variable may sometimes go up a lot between, let's say, a 1 and a 2, but between a 2 and a 3, maybe height goes up only a little bit. So that's what we mean when we say we cannot assume equal intervals. Now, statistics are still very limited. There's not a lot of math that we can do on numbers that are from this ordinal scale. Now, we can still calculate, let's say if there were ties, we could calculate the mode, the most frequent score. If we felt relatively convinced that there were, lots of people of the same height, we could say there's a tie, so there's a mode. All right. The other thing that we could do here, as soon as we have numbers that are in order, we can calculate something called the median. The median is an average, and the median is simply the score that is right smack in the middle. As long as you first have to order all your scores from lowest to highest, and then you identify the score in the middle. So we could, as long as, again, we have rank order, because that's part of calculating the median, right? You've got to rank order your data. Once we have that, we can calculate the median, and we can calculate the mode, but that's pretty much it. But at least it's better than nominal, where we could only calculate the mode. All right?